Hey, what's going on, guys? Welcome back to another video. This is Trig Identities Part 2, and it's Part 2 because this part is only for grade 12, because we only learn this in grade 12. Unless you're in grade 11 and you've learned it, then welcome. But it's Part 2 because we are actually now using our compound angle formulas to prove our trig identities. If you haven't seen Part 1, I'll leave it in the description below. That's just basic trig identities. And if you also want to see how we derive our compound angle formulas, I'll leave a link to that video down below as well. Without further ado though, let's just get right into it. So cos of x plus y times cos y plus sine of x plus y times sine y equals cos x. Now, when dealing with trig identities that include our compound angles, we want to expand them into what we know. And in some questions, you want to do the reverse. And you'll see what I mean by that later on in the video. But in this case, let's go ahead and expand our cos x plus y and our sine x plus y. So now on our left side, we get cos x cos y minus sine x sine y. And that's just being multiplied by cos y. Now let's do sine x plus y plus, this becomes sine x cos y plus cos x sine y, and we're multiplying that by sine y. Just like that. Now from here, let's just run this multiply right through, because this whole thing is being multiplied, right? So let's keep going with it. Cos x cos y times cos y gives us cos x cos squared y. And negative sine x sine y times cos y just stays negative sine x sine y cos y. Now let's look at this bracket. Sine y times sine x cos y becomes sine x sine y cos y. And finally, cos x times sine y, well, cos x sine y squared. So now that we've done this, what we can see, what we look for in this state is anything that zeroes out. And immediately, right in the middle, we have two of the exact same term, sine x sine y cos y, sine x sine y cos y. One is negative and one is positive. So we right away know that these zero out, just like that. So now we're left with cos x cos squared y plus cos x sine squared y. Just like that. Now, our final answer is cos x. So that's what we are trying to get to here. And we know that sine squared x is equal to 1 minus cos squared x. Basically, what we do in a situation like this is we want to make them all what we need it to be. We need it to be cos x. So we're going to change everything we can to make it into cos x. So that just means that I change the sine square x to a 1 minus cos squared x, just like that, because these are equivalent. Now let's expand this bracket. We get cos x cos squared y plus cos x minus cos x cos squared y. Finally, from here, same thing that we did up here. These two are the same. They zero out because one is negative and one is positive. 0, 0, and we get our final answer to be cos of x, just like that. Now, let's take a look at our right side. There. Right side is equal to cos x. Are they equal? Yep, they are. Therefore, Q, E, Z. Let's move on to the next one. Okay, now let's take a look at the second one. I'm sorry about the lighting problem. There, I think that fixed it. But anyway, it's cos of 3 pi over 4 plus x plus sine of 3 pi over 4 minus x. All that equals 0. Now, This one is a little bit different than the last one because now we have actual values. Values that we know hold something. But as we did in the last one, and as we should be doing from here on out, we're going to expand them into our formulas. So this becomes cos 3 pi over 4 cos x minus sine 3 pi over 4 sine x. That's the first one. And now this one is going to be plus sine 3 pi over 4 cos x minus sine x cos 3 pi over 4. Now, the only reason I did that so quick is because I have them memorized. Teachers aren't going to expect you to have them memorized, but after a certain point, you will eventually memorize it whether you want to or not. Anyway, let's keep going with this. Now, what makes this one different, like I said, is we have values, and we know these values. Cos of 3 pi over 4, if you guys don't have it memorized yet, you could always just put it in your calculator. But cos of 3 pi over 4 is actually negative 1 over root 2. And the reason it's negative is because 3 pi over 4 lies there, CAST, and cos is negative in this quadrant. So we can change this to negative 1 over root 2, and the cos x stays there. Now, sine of 3 pi over 4 is positive 1 over root 2 because sine is positive in this quadrant. So it stays positive 1 over root 2, and the sine x also stays. Let's keep this going. Sine of 3 pi over 4, as we just said, we know it's positive, so plus 1 over root 2 cos x. And finally, a negative, but cos is negative, so this just, a negative minus a negative is a positive, and we get sine x, well, 1 over root 2 sine x, essentially. Just like that. Now from here, we can do our zeroing. Negative 1 over root 2 cos x plus 1 over root 2 cos x. That zeroes out nicely. Negative 1 over root 2 sine x plus 1 over root 2 sine x also zeroes out quite nicely. And we get our final answer to equal 0. Well, now let's take a look at the right side. 0. They're equal. Therefore, QED. Just like that. Let's move on to the next one. Okay? Now, this one here is a little bit different. And you'll see why in just a moment. But if we take a look at it, maybe it looks familiar, maybe it doesn't. Your first step here might be to expand our tan x minus y, correct? Well, we know what that is, like we know how to do that. But doesn't this look a little bit familiar to you? It does to me. I'm an actor, by the way. Anyway, we know this. We know what that is. If we have tan of x plus y, we know that this expands to tan of x plus tan of y divided by 1 minus tan x tan y, correct? We know this. Don't those look the exact same? Well, that's because they are. Now, the only difference is x minus y is being treated as one term here. And that's what we're going to take a look at in just a moment. But to simplify things, here's what we're going to do. We're going to write left side, and we are going to say sub, let's say a. Sub a equals x minus y. And we're just going to rewrite this. So it becomes tan a plus tan y divided by 1 minus tan a tan y, just like that. Now that looks familiar, doesn't it? Because we know what this is equal to. We know that this whole thing is equal to tan of a plus y, just like that. And now from here, I'm just going to sub x minus y right back into it. So this becomes tan of x minus y plus y, just like that. And from here, well, we can simplify. We can simply say, okay, when we expand out the brackets, which we don't really have to do anything, negative y plus y equals tan of x. Well, let's take a look at our right side now. Our s is just tan x. They're equal, right? Yeah, they are. Therefore, QED. Now, I know I said earlier you don't have to memorize them, and you don't, like you really don't. But it's always good to have a general idea of how they look, especially tan, because questions like this, I guarantee, will be on tests or quizzes or homework or something. I can promise you that. And it would take forever if you would have expanded these and then, solved it and whatever. That would have taken so much longer than these simple 1, 2, 3, 4 steps. So it's always good to have a general idea of what you're doing, why you're doing it, stuff like that. But with that being said, let's go on to the next one. Okay, now let's do the next one. Now this one right here is a tough one, I'm not gonna lie. When I first did it, it took me about 20 minutes, a lot of erasing, a lot of frustration, but I finally got it. And I have to say, it feels good when you finally get something like that. But let's just look at it. So it's tan of x over 4 plus x minus tan of x over 4 minus x divided by tan of pi over 4 plus x plus tan of pi over 4 minus x. All that equals 2 sine x cos x. So let's break it down, shall we? Let's take a look at our left side. Now, the way I did it the first time was I expanded everything. And that's exactly what I'm going to do with you guys. So this becomes tan pi over 4 plus tan x divided by 1 minus tan pi over 4 times tan x. So that right there is our first one. Let's move on to the next. That is being subtracted by tan of pi over 4 minus tan x divided by 1 plus tan, oh my god, my marker. 1 plus tan pi over 4 tan x. Now let's work on the bottom. All that is being divided by, now this right here, tan of pi over 4 plus x, we know what it is because we just did it. So we can basically just copy like literally what's on top of it. Just like that, divided by 1 minus tan pi over 4 tan x. And now we're adding, and once again, this is the exact same as that. So we're just going to really just copy what's on top. 1 over tan pi over 4 tan x divided by 1 plus tan pi over 4 tan x. Beautiful. Now this seems like a lot. Let's work on it just a little bit. What is tan pi over 4? If we put that in our calculator, what is it? Well, it's 1, isn't it? So immediately, this gigantic thing just got a little bit smaller. We're just basically, at this point, we're going to turn all our tan pi over 4s into 1. Tan x, just like that. Now, if you've seen my last video, you have a general idea of what we're about to do. If you haven't, go watch it, I guess. But we're just going to make the denominators of this part the same. And the way we do that is we see what it's missing and we're just going to multiply that through. So, for example, in this case, it's 1 minus tan x, and in this case, it's 1 plus tan x. So, essentially what I just did was I made all of the denominators everywhere here equal to each other. And the way I did that was I multiplied this by 1 over tan x over 1 over tan x. Sorry, 1 plus tan x over 1 plus tan x. Multiplied this by 1 minus tan x over 1 minus tan x, and so on. Now we have this really long thing, and it sucks, but we have to expand it. Now, luckily, this is all going to be difference of squares or perfect cubes, which we know how to do. So I'm just going to cut ahead to when I actually write that out. Okay, So once we finally expand this lovely equation, we get this. And now I'm actually just going to take this, I'm going to put it up there, and I'm going to rewrite it to simplify so we can see what the next step really is. So essentially what I did to get from that to that is, since they have the same denominator now, we can actually subtract our tops. So that's exactly what I did. I took the subtraction, I ran it all the way through to give us -1, +2, and negative tan squared x. And I did the same on this side, where I just put it all on the top. Now, from here, we can start simplifying. So, let's look in the top for anything that we can reduce. We have 1 and we have -1, so that immediately becomes 0. There we go. We have +2 tan x and +2 tan x, so that becomes 4 tan x. Okay, we took care of that. And we also have tan squared x minus tan squared x, which is just 0. So we are left with 4 tan x divided by, I should say over 1 minus tan squared x, just like that. Now let's take a look at this side. That whole thing is now being divided by, can we do anything here? Well, we have 1 plus 1, so that becomes 2. We have 2 tan x minus 2 tan x, so that zeroes out. And we have tan squared x plus tan squared x, so it's 2 plus 2 tan squared x, all divided by 1 minus tan squared x, just like that. And now we have a division here, so we're just going to flip this. We get 4 tan x over 1 minus tan squared x times 1 minus tan squared x divided by 2 plus 2 tan squared x, just like that. Right away, what we see, well, that can cancel out. And something else that we can actually do, I'll actually do it in the next step. So from here, we get 4 tan x divided by 2 plus 2 tan squared x. And what we can do to this is we can actually factor out a 2. So we can do it 2 times 1 plus tan squared x, just like that. And the reason we did this is because now that can become 1 and this can become a 2. So from here, I've room. This becomes, actually I'm going to write it over here, 2 tan x over 1 plus tan squared x, just like that. Let's keep going with this question. So now from here, we've got it very simplified. We went from this massive thing to this. And we want it in terms of sine and cosine. So what do we do now that we've got it basically as simplified as we can? We're going to turn all of our tans into sine over cos. So this becomes 2 times sine x over cos x, right, that's the top, divided by, we're going to change the 1 in just a moment, but we'll see how this goes. 1 plus sine squared x over cos squared x. And like I said, we're going to change the 1 to cos squared x over cos squared x. Just like that. So from here, let's just simplify. 2 sine x over cos x, and we are dividing it by cos squared x plus sine squared x equals 1 over cos squared x. Now this division, we flip. So this equals 2 sine x over cos x times cos squared x, just like that. And from here, finally, that crisscrosses. This has an exponent, it just subtracts by 1. And we get our final answer to be 2 sine x cos x, just like that. Let's look at our right side. 2 sine x cos x. Are they equal? Yes, they are. Therefore, QED. And we just did one of the hardest questions that you will ever get in a grade 12 math homework sheet or test or quiz or anything like that. Let's move on to the next few. All right, moving on to the next one. Sine of pi over 2 minus x times cotangent of pi over 2 plus x equals negative sine x. Now, this one, right away, you guys, once again, might be very inclined to expand and expand. And absolutely, you could do that. However, you don't know how to expand cotangent of that, but I'm sure you figure it out. It's not too hard. But here's the thing with this question. If we take a look at it, pi over 2 minus x, that is a correlated angle. We can rewrite that immediately. We can also do the same with the cotangent. And the way I know that, and the way you should be looking at questions like this from now on, is as soon as, right here, as soon as you see either pi over 2 or 3 pi over 2, regardless of whether it's plus or minus something, as soon as you see that, that's when you know it's a correlated angle. That's it. You don't even need to expand it. That's just so much extra work for you. As soon as we see that, boom, correlated angle. As I was saying, this one right here, sine of pi over 2 minus x, lies in here, right? Because pi over 2 minus x is right there. Is sine positive or negative there? It's positive, so we know that it's going to be positive cos of x. And if you don't know that, go watch my correlated angle video. I'll leave it in the description below. But basically, it explains like why that is. And well, correlated angles are a pretty big part of the unit, so it's really good to understand them. Anyways, cotangent of pi over 2 plus x. Now, this lands over here. Now, is cotangent positive or negative here? It's negative. So we know that this is going to be a negative tan of x, just like that. And well, from here, we can just simplify. Cos x times, what's another way of writing tan of x? Well, sine x over cos x. Sine x over cos x. Just like that. Criss-cross, we get negative sine x. Let's take a look at the right side. Negative sine x. Boom, boom. Therefore, QED. Just like that. Okay, one of the last ones. Sine of pi minus x times cos of pi plus x times tan of 2 pi minus x divided by secant of pi over 2 plus x times cosecant of 3 pi over 2 minus x times cotangent of 3 pi over 2 plus x all equals sine to the power of 4x minus sine squared x. Now, what I said in the last example about as soon as we see 3 pi over 2 and pi over 2 still stands. It makes our life that much easier. Now, something else we can do is look at just our regular related acute angle. And the way we do that is if we're given pi plus something or pi minus something, or 2 pi plus or minus something. Same way we look for 3 pi over 2 and pi over 2, we do the same for the other one. Now it's just a little different, and I'll walk you guys through it. Sine of pi minus x, if we want to draw it out, pi minus x gives us that, right? C-A-S-T, just like that. Well, sine of pi minus x, sine is positive here. So it's the same as saying positive sine x, right? It is. That's what we've been seeing throughout the whole unit so far. So we can just keep this as sine x. Now the reason we're going to do this for every single one is because it's much easier and much faster than expanding these using our compound angle formulas. And it goes by a lot quicker. Now, cosecant, cosine of pi plus x lies down here, with x being that angle. Is cos positive or negative down here? Well, we know it's negative, so it's going to be negative cos x. Next up is tan of 2 pi minus x. So 2 pi is all the way over here, minus x is right here. And once again, tan is negative here, so it's going to be negative tan x. Now, secant of pi over 2 plus x. That lies right over there. Now, is secant positive or negative here? Well, secant, as we know, is cosine, and cosine is negative here. And the correlated angle of secant is cosecant. It's basically the opposite one, right? So, since it's negative up here, this becomes negative CSC of x. Now, cosecant, or the reciprocal of sine, 3 pi over 2 minus x. 3 pi over 2 is down here, and we're subtracting x. Is sine positive or negative down here? Well, it's negative, so this becomes negative secant of x. Finally, is cotangent of 3 pi over 2 plus x, and that lies right over here. As we know, that is negative for cotangent, so this is going to be negative tan of x, just like that. And now with all this, right away, tan x, negative tan x, these two can cross out very nicely. And we are left with negative sine x cos x divided by, these two negatives also cancel out, just like that, divided by CSCX SECX, just like that. Now, cosecant and secant of x are 1 over sine and 1 over cosine. So, we are just going to change this to 1 over sine x times 1 over cos x. And that really just gives us 1 over sine x cos x. Just like that. So now we're dividing, we can do our nice little flip. We get sine x cos x times sine x cos x over 1. And from there, really all we're doing is just multiply. So we get sine x squared and cos squared x, just like that. Now, we can do this in one of two ways. We can keep going with this to get to that, or we could use this to get to that. And just for the sake of room, I guess, I don't really want to draw any arrows, we are going to take a look at our right side now. Right away, we see we have a common factor of sine squared x, right? Sine squared x times sine squared x minus 1. So sine squared x times sine squared x gives us sine to the 4x minus sine squared x. We just factored out our sine squared x. Now, sine squared x minus 1, what does that give us? Well, if we take a look down here, my apologies, I forgot a negative somewhere. Yeah, there was a negative right here and I forgot to run it through. There we go. So sine squared x minus 1, do we know what that is? Not really. We know 1 minus sine squared x. 1 minus sine squared x equals cos squared x, right? Well, what if I was to move this over here? Negative cos squared x plus 1 minus sine squared x equals 0. Now I have this. And we can keep going with this to give us negative cos squared x equals positive sine squared x minus 1. Right? That's equal. And we showed it mathematically. Another way we could have done it is just multiply both sides by negative 1 to show us that it's equal. But negative cos squared x is equal to that thing right there. So that's exactly what we're going to look at. this now equals sine squared x times negative cos squared x. And our final answer becomes negative, well, I don't know why I changed the order, negative sine squared x times cos squared x, just like that. Are they the same? Yeah, they are. Therefore, QED. So just a quick recap of what we did and the concept that I wanted you guys to get from this example in particular. As soon as we're doing compound angle formula questions, proving them like trigonometrically speaking, if we see pi plus or minus, if our unit circle looks like this, it has pi over 2, it's got 2 pi, and it's got 0. Here it has pi, and here it has 3 pi over 2. As soon as we see any one of these four, not really 0, that doesn't count. As soon as we see any one of these four in this spot right here, we don't need to use our compound angle formula at all. We can just find the equivalent of it using our knowledge with correlated angles and our knowledge with related acute angles. Obviously, using cast as well, that's very important. You don't want to get the negatives wrong, otherwise it will mess you up. But yeah, I think I'm going to leave it at that for today's video. Hope you guys enjoyed. If you want me to do a part 2, I have a bunch more questions. Please leave it in the comments below. If you want any specific math concept, anything at all, physics even, I don't care. Leave it in the comments below. If this helped you, please share it. And yeah, have a great day.